Okay, let's look at some examples of this preliminary stuff. So, interval notation, as you see, obviously, is basically a shorthand to write a large series of numbers. And in general, an infinite series of numbers. Because if I look at some of my examples I've put here, like x greater than or equal to -2, there are infinitely many numbers that are greater than or equal to -2. Every positive number is greater than -2. -1 is greater than -2. 0 is greater than -2. So there are a lot of them. So the way we typically do this is we will make our number line for each of these. And we'll kind of sketch what this looks like. So if -2 is here, the numbers bigger than -2 are going to be to the right. So it's all these numbers. And then for -2, we include the number with a solid dot and we exclude it with an open dot. So since I have put a solid dot there, that means we would include -2. If it was an open circle, then it's bigger than -2 but not equal to. Now, when we do interval notation, we do the smallest number to the biggest number, remembering that if we want to include it in interval notation, the bracket means we include it, and the parenthesis means we is not included. So in this first one, we always go from the smallest to the biggest. So in this red arrow, this is the smallest, and it's always on the left. And the biggest is going to go forever and ever and ever and ever. So that's going to essentially be infinity. Because as you go larger and larger and larger and larger, you get off to infinity. So when I do my interval notation, I'm going to start with my left point with a -2. And notice I put a bracket because I'm including -2, because that is part of the solution. And then I'll put infinity for the biggest because it keeps going. Infinity by definition always gets a parenthesis. Because since infinity is not a number, you can't actually be equal to infinity. So that's why we always use a parenthesis. Now if we look at the second example, it says x is less than 4. Well, here's 4. And if I want numbers less than 4, if I think of this as a number line, well, here's 3, here's 2, here's 5. The numbers that are smaller than 4 in this case are to the left, forever and ever and ever and ever. But in this case, I do not include 4 because it doesn't have this line. This line means equal to, and we don't have that for the 4, so it has to be strictly smaller than 4. So if I said someone had to be, younger than 21, if they're 21, that does not count. So in this case, same kind of idea, but the smallest in this case, they keep getting smaller forever. So we could consider numbers getting smaller forever negative infinity. So you could think of this as negative infinity to 4. Negative infinity is smallest, and it always gets a parenthesis. Now 4 in this case is an open circle, so it also gets a parenthesis. So you get the 2 parentheses in this case. All right, now the last one says x is between 7 and 10. So whenever you have two numbers, you're basically looking at the numbers in between these two. And the only difference is one side has an equal on the 10 and one side does not on the 7. So remember, if it's included, I'll put the solid dot, and if it's not, I'll put the open circle. And so my interval notation in this case is going to be parenthesis 7, comma 10, close bracket, because I'm including it. Now the second big thing you see in this section is talks about domain and range. And domain is obviously going to be the set of all x values. So every x value a function can take on, and range is going to be the set of y values. Now I put a couple examples here. One that's kind of a closed one where it has you can see it has a closed circle over here and an open circle over here. And this one has a closed circle here, and then just kind of keeps going. The arrow means it's going to keep going forever and ever and ever. Now, what a lot of people get confused at is you essentially see 5 points listed here, but this function, this graph actually has lots of points. Because if you think about it, all these points on this graph, all these little points, all these points going on this has infinitely many points. So that's why we're always going to have to use interval notation. So the domain, we're going to have to think of all the x values, of all the possible x values, which has the smallest x. And I think we can agree that -3 would be the smallest x. And if I look at all the points, 4 is the largest x. You can also think of this as which one is furthest left and which one is furthest right. But of all these points on this graph, -3 is the smallest and 4 is the biggest. So my domain would simply be -3 in brackets, and I do a bracket because you see it's got the closed circle dot. And on the upper end, I have 4, but it is a parenthesis because it has the open circle. Most of the time, graphs do not have open circles, but just for these kind of preliminary things, we can certainly put one in. But when you see functions in general, they will not have that. Range is the same thing, but range is the y value, so the up and down. So if I look at all these y values, and again, it's just not these points, there are infinitely many points. But I think the smallest y is this -2. It doesn't have to be at the same point as the x, but it is here. And I think the biggest y is this 2. There are no points that have a y bigger than that or smaller than -2. And since this one's closed circle, so that one's definitely a bracket. If it's just kind of part of the curve, if it doesn't have an open circle, we'll assume it's included. So that's going to be -2 to 2. So that would be the domain and range for that relation. Now if we look at this last one I made up, so you can see that, again, this has lots and lots of points, but these points keep going forever and ever and ever. Now it's an important fact to remember that as this goes to the right, the x values are getting bigger and bigger and bigger and bigger. Because as you go to the right, these points are having larger and larger and larger x values. But the y values are getting smaller and smaller and smaller and smaller. Because it's going down. Now as it goes to the right and down, the x's get bigger, but the y is getting more and more and more negative, so they are decreasing. So when I think of my smallest x, my smallest x is going to be this -2. And it's a closed circle, so it's going to be included. But the x's keep getting bigger and bigger and bigger and bigger as it goes off to the right. So the domain is going to be -2 to infinity because it keeps getting bigger and bigger and bigger and bigger. Now the range is a little tricky. Now this -1 here, this is actually the biggest y. Because the y's go down from there. They get smaller and smaller and smaller and smaller. They get small as you want. So the range is actually going to go all the way down to -infinity. That's the smallest it can go, because this can go down and down for as long as you want. And the biggest is going to be -1. It's a little reverse there, because it's going backwards. Now, if it was flipped the other way, kind of the one on the worksheet, then you could go off to positive infinity. But this one, I figured we do something a little different. So that's just a little bit about domain and range, interval notation. Obviously, if you have questions on this, please let me know.